I have returned to you after a year or so of not making any videos, and I just kind of felt like doing one today. So we're going to do problem 9 of Project Euler, again in Scala 3. So here's the problem. It tells us that a Pythagorean triplet is a set of three natural numbers, a, b, and c, where a is less than b and b is less than c, such that a squared plus b squared is equal to c squared. So the classic example is 3 squared plus 4 squared is the same as 9 plus 16, it's the same as 25, which is the same as 5 squared. And then they're telling us there's exactly one Pythagorean triple, for which a plus b plus c equals 1,000, and our task is to find the products of a, b, and c. So to be honest, I think we can just brute force this, which is how I do all of the projects or solutions usually. And the reason I think that we will be able to is because of this constraint where they have to sum to 1,000. That means that the largest any of them can be would be if c was 1,000 and a and b are both 0. Now I know that's obviously not an actual triangle, but the point is that all of them individually have to be less than 1,000 in order for them to sum to 1,000. So if I just iterate the values of a, b, and c between 1 and 1,000, we will get the answer. So let's try it. Let's try that. Yeah, I think what I will do eventually is I'll just sort of I'll try and optimize this a bit later. So we know that we need the values to go from 1 to 1,000. So iterated up range of 1 to 1,000 will give us exactly that. We know that we need three values, a, b, and c. So I think the appropriate way to combine stuff is with the for comprehension. I can't type, as anyone who's watched these videos before well knows, but it's fine. So if we just do something dead simple like this, and then do a simple check to see if they really are sort of Pythagorean around here-ish, that will give us the answer. That will find it for us. So I think I will do that first, and then I'll try and figure out if we can optimize it, because not only is this inefficient in that it's exploring more values than it strictly needs to, it'll also be inefficient in that I think it'll give us the same answer more than once. But let's see what actually happens, right? So we'll obviously need a function that tells us, is it Pythagorean? I'm not going to be able to spell Pythagorean. It's not going to happen, is it? But let's see. So c, yep. And then this is true if a squared plus b squared is equal to c squared. Nice and easy. And, let's use double equals. Let's not assign naughty values. Alright, let's try and use this function that we have. And the other constraint, obviously, was that they have to sum to 1,000. So we'll add that one. So that's a plus b plus c. And, I've learnt from a mistake. Double equals there. And obviously these guys need some ifs on them. And then we will yield out. Let's just yield out a times b times c. Cool. All right. And then if we give this a name like that, and if we sort of just go and we just tell it to print out everything it gets, hopefully it will spit out one number, or rather one number a couple of times. I hope. Let's see. It's not very happy, this, is it? It took 8 seconds to run and didn't print anything. Okay, well firstly, let's put 1,000 there. Let's try that. So that's printed out a number and another number, which I suspect is actually the answer. But as you can see, this takes a very long time to run. So first, let's check if this is the answer, and then let's check if we can optimize this a little bit, because it definitely needs it. It shouldn't take 8 seconds to work out something that's as straightforward as this. Is this check going to go through? So that is the correct answer, but we can calculate it much more efficiently. So let's do that. Is this? So I think there's two things we can do. I think the first one is that we don't actually need to iterate over c, because this constraint essentially tells us what value c has to be in order for us to find a Pythagorean triple that has values that add up to 1,000. So instead of like iterating, we can actually just say c is 1,000 minus a minus b. Now, there's a problem with that, because if we know the triangle inequality, we know that sometimes this quantity here, c, can potentially be negative, which we don't ever want to happen. So I think we'd have to guard against c being greater than 0, which is fair enough. And I think this is probably the more important of the two optimizations. So let's see what this does. Let's see if this makes it any faster. So that's running like 100 milliseconds now. The other thing I believe we can do is we know that a is less than b is less than c. So what we can do is we can make sure that a really is less than b. And the way we can do that is just if we change the for comprehension a bit like this, and we make sure that a is less than b by putting b as the upper value on the range, and further we need to check that c is the largest, so c has to be larger than a, and c has to be larger than b. And like obviously I know that if obviously if c is larger than b, it's automatically also larger than a, so actually we don't use the c is larger than a constraint, I don't think. And I believe what this will do is it should only find one of the triples, because what we were doing before is we'd essentially sort of swapped like a and b around, and that's why we double counted it. So let's see what this does. Yeah, so it comes at once. It takes about the same amount of time. The real trick here is using the constraints to mean that you don't need to do more iteration. And I think that's an idea that I've used in quite a few of these problems, actually. So yeah, because I'm only doing these videos like after I've solved them. I've actually solved quite a few of them. But yeah, that's the answer, and we've managed to optimize it, so I'm fairly happy with that. And I think I'll leave it there. Thanks for watching. I think the only difference between this and the old videos is my face doesn't appear. Some would probably argue that that is a good thing. It's just because I have a different laptop, or rather, I don't have a laptop anymore, so I don't have a camera. But I think I think the main bit of these videos is very much the coding. If you really want to stare at me, I guess follow me on Instagram or something. Alright, thank you for watching. Good day.